everyone! In this video, we're going to take a look at electrophilic aromatic substitution reactions. So the name is kind of a mouthful and it's often abbreviated EAS, but it's actually really helpful in understanding what's going on in the reaction and what's involved in it. So for example, if we take a look here, we've got benzene, and benzene is an aromatic compound, which is why this has aromatic in it. And it's going to be reacting with this electrophile Y+. So now we understand electrophilic here, aromatic here. So now this Y+ is just a generic stand-in. There are a lot of different electrophiles that could be used to do this particular reaction. And we're going to see that the substitution reflects the fact that the electrophile is going to substitute out one of the substituents on your aromatic chain, such that the final product now has that electrophile as part of the aromatic compound. And then that H+ has been kicked off. Okay, so now let's take a look at the general mechanism for this reaction. So over here we have our aromatic compound. In this case we have benzene, and this is going to be our generic electrophile. So now there are a lot of options for what that electrophile could be, and there are generally a few preparation steps in order to prepare it for reaction, but for now we're just going to call it Y+. So now in the first step, one of those pi cloud electrons is going to come and it's going to attack our electrophile right here. And this is actually going to disrupt aromaticity, right? And aromatic compounds are particularly stable, so it's a little bit difficult to get these reactions going, which is why here we're going to have a two-way arrow or an equilibrium arrow, because we are disrupting aromaticity, so it could go back either way. The product that we would make over here now would have an sp3 carbon with the Y that we've added, our electrophile, and the hydrogen. So now we want to put some kind of base in the solution to help push it in the forward direction. And that base will come and it's going to pull off that hydrogen and collapse those electrons back down. And now we're going to be reestablishing aromaticity. So you'll notice that this is a one-way arrow because it would be very stable and very favorable to reestablish that aromaticity. And so we have our final products over here. So that's pretty much the general mechanism for one of our EAS reactions.